Good morning. Today we will continue our lesson which was talking about solving trigonometric equations using inverses. Now, before we start, I want now to remind you how can we find the sine and cosine for the main angles here. For angle 0, we say that the sine of 0 is 0. And also the sine of 360 also is 0. Cosine 0 is 1 and cosine 360 is also 1. And we say that the sine of 90 is 1 and cosine is 0. But for 270 the sine is negative 1 and the cosine also is 0. For 180 here we have 0 for the sine and negative 1 for the cosine. And also, we say that of sine 30 is 1 over 2, which is as the same as cosine 60. And we say also that the sine of 60, which is square root of 3 over 2, is the same as cosine 30, which is square root of 3 over 2 also. And 45, the sine of it is square root of 2 over 2 and the cosine of it is square root of 2 over 2. Now we will know how can we find the tan of these angles. Now as we said in the previous lessons or previous lessons, yes, we say that the sine of the tan of any angles, it was sine over cosine. It was sine over cosine. That's why. So here, what about tan? Say tan of 0. It is sine 0 over cosine 0. It means 0 over 1. 0 over 1 is 0. What about 30? 1 over 2 divided by square root of 3 over 2. 2 cancel 2. So it was 1 over square root of 3. Here, it was the same. Sine or cosine is the same. So sine over cosine here is 1. So every time you have to know that tan 45 is 1. What about 60? It is square root of 3 over 2 over 1 over 2. It's square root of 3. Here, for the 30, the tan of it is 1 over square root of 3, but tan 60 is square root of 3. What about 90? It's 1 over 0, which is undefined, or we called it not existed. So there's no tan for 90. For 180, it is 0. For 270, also it's not existed, and for 360, it is 0. So these are the table. Now, let's talk about the unit circle. We will remind you, talking about now the unit circle. As you see here, we say that we have an ordered pair, the first one for cosine and the second one for sine. In quadrant number 1, both of cosines and sines are positive. What about tan? We say that tan of theta is sine over cosine of theta. So positive over positive is positive. So here the tan is positive. What about here? It is negative over positive. So the tan here is negative. Here, both of them are negative. Negative over negative is positive. So in quadrant 3, the tan is positive, and here the last one, the tan is negative. So in the quadrant 1 and in the quadrant 3, the tan is positive. Okay. Now today we will know how can we find they or how can we solving the equation that for the trigonometric equation, how can we solve it using the sine inverse? Look at the first one here. What values for theta in this interval from 0 to pi to 2 pi, sorry, satisfy this equation? 2 sine theta minus square root of 2 equals 0. How can we deal with these types of equations? It is like 2x minus 3 equals 0. You will say plus 3 plus 3, then 2x equal 3, so x is 3 over 2. Did you remember how we solve this type of equations? Here is the step, but this one's linear, and here we talk about trigonometric equations. Here now we say 2 sine theta is equal square root of 2, because we put square root of 2 on the other side. Then divide by 2, divide by 2. So sine theta is square root of 2 over 2. Did I finish now? No, I want you to find the values of theta. So after that, the second step, you say theta is sine inverse of square root of 2 over 2. Then I will go back now to this unit circle. Now for the I say sine theta is square root of 2 over 2. What is square root of 2 over 2? It is pi over 4. It is 3 pi over 4. So it is pi over 4 and 3 pi over 4. Sorry. Okay. So theta is pi over 4 and 3 pi over 4. These are the two values of theta that the one here. I told you between interval 0 to 2 pi. Including this interval only, I want you to find the values of theta. Look at the second one now here. 2 cosine theta minus square root of 3 equals 0. It's mean 2 cosine theta is square root of 3. Divide by 2, divide by 2. So cosine theta is square root of 3 over 2. Then theta is cosine inverse of square root of 3 over 2. Which angle or angles that its cosine is square root of 3 over 2? Let's go to the unit circle. What is the square root of 3 over 2? It is pi over 6. It is also 11 pi over 6. So you will tell me that that pi over 6 and 11 pi over 6. Now, here now, what values of theta from 0 to pi satisfy this equation? 4 cosine theta minus 1 equals cosine theta. Now, for this one down here, first step, what? Minus cosine theta minus cosine theta. So it will be 3 cosine theta minus 1 equals 0. Then 3 cosine theta is 1. So cosine theta is 1 over 3. Then theta is cosine inverse of 1 over 3. Now, sometimes of equations here, as you see, you will not find 1 over 3. So you will need a calculator. I will put a video tell you how can we use the calculator to find the inverse of the angles. So using calculator, you will see theta is 70.52 degree. Now, here now another example. Sine theta minus plus 1, equal sine theta. I want now to find the values of theta inside this interval. Tell me that what is the angle, the values of theta. Yeah, let's try now. Minus here, minus sine theta, minus sine theta. So 2 sine theta plus 1 equals 0. Then sine theta 1 minus 1 divided by 2 divided by 2. So sine theta is negative 1 over 2. So theta is sine inverse of negative 1 over 2. 1 over 2, it is in a circle. Where is it? The sine is negative 1 over 2. It is on 7 pi over 6. And on 11 pi over 6. So theta is 7 pi over 6 and 11 pi over 6. Here now, what values of theta from 0 to pi satisfy this equation? 2 sine theta equal 3 divided by 2 divided by 2. Sine theta is 3 over 2. So theta is sine inverse of 3 over 2. Now, if you remember the domain of sine, I told you that the range of sine is from negative 1 to 1. So the sine, any value of any sine of any angles, the sine of it must be between negative 1 and 1. So for the sine and for the cosine also, you cannot find any value that's greater than 1. For the tan you can find. So sine 3 over 2 or 1.5. I told you there's no value that its sine is greater than 1. So you have to tell me that theta is, or you can say no solution. What values of theta from 0 to pi satisfy this equation? Sine theta plus 1 times sine theta minus 1 equals 0. How we deal with it? Here. Did you remember that you say 2 times 0 is 0, or 0 times 3 is 0. So if you multiply any two numbers and the answer is 0 is 0, so one of them is 0. As you see here, the second one or the first one, it's allowed to be 0. So here is the sum. Here is the sum. Here we can say that 2, sine theta plus 1 equals 0, or sine theta minus 1 equals 0, because the multiple product of any two numbers, if it is 0, so one of them is 0. So here it could be the first or the second one. Now sine theta plus 1 equals 0, so sine theta is negative 1. Here, sine theta is 1. Now, sine theta is negative 1, it's means that theta is sine of it is sine inverse of negative 1 using the table Which one has the sine of it is -1? It is 270. So theta is 270 degrees. Sine of theta is 1 and theta is at 90 degrees. Here now. Now, the second thing I want to tell you about it today, sometimes we can solve this type of equations by factoring. Like what? Like here now. Put values of theta from 0 to pi, satisfy this equation. 2 cosine theta, sine theta plus sine theta equals 0. Like 2xy plus x equals 0. Can we put x as a common factor? Yes. So x is 2y plus 1 equals 0. Now, I told you before, we have two numbers that they are multiplied and the answer is 0, so one of them is 0. So here, x could be 0 and 2y plus 1 could be also 0. Now, here's the sum. Now, 2 cosine theta, sine theta plus sine theta equals 0. Can I take sine theta as a common factor? Yeah, let's try. Sine theta as a common factor. You will have 2 cosine theta plus 1 equals 0. So, sine theta is 1 or 2 cosine theta plus 1 is 0. So now I have two equations. Now where is sine theta is 0? At which angles? At 0. Okay, the term is from 0 to pi only, so I have to use it from 0 to pi only. 2 cosine theta plus 1 equals 0. So 2 cosine theta is -1. So cosine theta is -1 over 2. So theta is cosine inverse of -1 over 2. Let's go to the unit circle. Search about cosine is -1 over 2. Cosine is -1 over 2. Cosine is negative, so I'm talking about quadrant 2 and 3. Look, let's look here. Where is it? It is at 2 pi over 3 and at 4 pi over 3. So theta is 2 pi over 3 and 4 pi over 3. But 4 pi over 3, it's not in my interval, so I will choose only 2 pi over 3. And here it's from 0 to pi, and the pi is not included, so I choose only 0. Let's look here now. Tan theta is equal to tan squared theta. So tan squared theta minus tan theta is equal to 0. Can we take a tan as a common factor? Yes, take tan as a common factor. So we will have tan theta minus 1 equals 0. So tan theta is 0 over tan theta is 1. What is the tan is equal to 0? At which values? Let's go to the table here. 0 for the 0 and for 180 and for 360. So it could be 0, 180 and 360. But he wants from this interval, so I say theta is 0. What's about here now? Tan theta is 1. I told you there's only one angle that its theta is 1, which is 45. Now, also you can find in quadrant 3, also we have another angle that its tan it is 1, but my interval is from 0 to pi, so I will not look at quadrant 3. Now here, sine squared of theta plus 3 sine theta equals 0. Yes, take a sine as a common factor. Sine theta, so you will have sine theta plus 3 equals 0. So sine theta equals 0 and sine theta negative 3. Now, sine theta equals 0. We say that at point 0. Sine theta equals negative 3. I told you that the domain of the sine is from negative 1 to 1. So there's no value at point negative 3. So I say no solution. Look here now. For this one now, we have sine theta minus 3 sine theta equal to. How can we deal with it? Here we have x squared plus bx plus c equals 0. For this one, it is a quadratic equation. Why would I deal with it like this? Here we have the constant is 0. So if the constant is 0, I will deal with it as a common factor. But see, the constant is not 0, so I must use it or solve it like quadratic equations. Let's do. It will be sine squared of theta minus 3 sine theta minus 2 equals 0. Like x squared minus 3x minus 2 equals 0. How can we deal with that equation? We say x minus 2 minus 1. So minus 2x minus 1x is minus 3x. So x it could be 2. And here is the sum. But instead of x, you have to write sine theta minus 2 minus 2. I'm sorry, here we have something wrong. Minus 3 equal to, so minus 2 equals 0. It must be plus. So minus 2 and plus 2 minus 1. No. I'm sorry. Make it plus negative and here is positive, so it will be, now it will be true, yes. So minus 2 minus 2 minus 1, because negative 1 times negative 1 is positive 2. You add them and they are negative 3. Okay, so the sine theta here would be 2, and the sine theta would be 1. Sine theta equal to, there is no solution. Why? Because the range is from negative 1 to 1. Sine theta equal 1, yes, there's a value. That's 0.5 over 2. What we call them? We call it, 90. Look here now. 2 sine squared of theta minus 1 equals 0. For this one now, it's like 2x squared minus 1 equals 0. Before it, if you have x squared minus 1, how can we factorize it? You will say it's x minus 1 times x plus 1. Here is the same, but you will say positive as square root of 2 x minus 1 times square root of 2x plus 1. So here it will be square root of 2 sine theta minus 1 times so it will be square root of 2 sine theta minus 1 times square root of 2 sine theta plus 1. It's like x times my x minus 1 times x plus 1, it will be x squared minus 1. So, to the first one, square root of 2 sine theta minus 1 is equal to 0. So sine theta for square root of 2. Sine theta is 1. So sine theta is 1 over square root of 2. So theta is sine inverse 1 over square root of 2, or we can make it as 2 square root of 2, which is 45. So at angle 45. The second one now. Square root of 2 sine theta equal negative 1. So sine theta is negative 1 over square root of 2. So theta is sine inverse of negative 1 over square root of 2. Now let's go to the here. Sine theta is negative 1 over square root of 2. Or negative square root of 2 over 2. Why is it? That's 3 pi over 4. So here I will repeat. It is negative 1 over square root of 2. It is like square of 2. So theta here is 135 degrees. Now here, 2 sine squared of theta plus cosine theta minus 1 equals 0. For this one now, we have to use the Pythagorean identities that we said in it. Sine squared of theta plus 1 plus cosine squared of theta. I will use it now to put instead of sine squared 1 plus cosine squared. So 2, 1 plus cosine squared plus cosine theta minus 1 equals 0. Then after multiplying, 2 plus 2 cosine squared of theta plus cosine squared of theta minus 1 equals 0. So it will be 2 cosine squared of theta plus cosine squared of theta positive 2 minus 1 is plus 1 0. Then by factorizing. Now 2 cosine theta times cosine theta, okay, and positive 1, we can write it as now it is positive 2 minus 1, it is positive 1, yes. So we can write it as now negative 2 cosine theta plus cosine theta plus 1. I can write it as 2 cosine squared of theta minus cosine of theta minus 1 equals 0. Let's multiply by negative 1. This one now, cosine times cosine, negative 1 and 1. If you put negative here, it will be negative cosine plus positive 2 cosine, so positive here, negative here, so it will be cosine minus 2 cosine is negative cosine, yes, equals 0. So 2 cosine theta is negative 1. So cosine theta is negative 1 over 2. So theta is cosine inverse of negative 1 over 2. Where's the sine is cosine inverse at negative 1 over 2? Let's go. Negative 1 over 2. Cosine is negative. So I'm talking about quadrant 2 and quadrant 3. at 120 and at 210. 120 and 210. Now look here, the interval is until 2 pi, so 210 is included. The second one, cosine theta equal 1. So theta here has cosine inverse of 1. At which angles the cosine is 1? At angle 0 and 2 pi. But 2 pi here is not included, so at 0 only. Now, look at the last one here. Put the values of theta from 0 to 2 pi, satisfy this equation. 2 sine theta plus 1 equal cosecant theta. The first step, I will rewrite it as 2 sine theta plus 1 equal 1 over. This is with letter C, so down will be with letter S. Then, by cross multiplication, 2 sine theta plus 1 times sine theta is equal 1. So it will be, after multiplying them, it will be 2 sine square root of theta plus sine theta equal 1. So 2 sine square root of theta plus sine theta minus 1 equals 0. It comes as quadratic equation. Yes, it will be 2 sine theta times sine theta 1, 1. Then negative 1 for positive and negative. If we have but here negative, it will be negative 2. So here we have positive and here we have negative. So negative sine plus 2 is positive sine. Okay, then these are equal 0. So 2 sine theta equal minus 1 equals 0, which is mean 2 sine theta equal 1. So sine theta is 1 over 2. So theta is sine inverse of positive 1 over 2. At which angles we have positive 1 over 2? At angle 30. So theta is 30. Only 30? No. Let's go to the unit circle. Which angles have the sign of 1 over 2? 30 and 150. And also, so this is part 30 and 150. Sorry, I will repeat it. 2 then we put here 1 and we put here 1, then we say negative star plus positive, yes. Then equals 0. Which means 2 sine squared of theta, without square, sorry. 2 sine squared of theta equal 1, so sine theta is 1 over 2. So theta is sine inverse of 1 over 2, and we found from the unit circle it is angle 30 and 150. What about the second one now? Sine theta is -1. So theta it will be 270 degree. Now you have homework page 909, exercise 67. Where is it? I'm sorry, no, from 45 to 53. I have a mistake, from 45 to 53. This is your homework. Please solve it. It's cancelled. Please solve it from 45 to 53. Thank you for watching.